Hey everyone, it's Lawrence from Vanalist here, and I'm excited to show off another set of updates to our electronics cooling simulation app. So today I'm going to run a simple simulation of a PCB that's sitting in a kind of server rack enclosure. So first of all, we've got our PCB that we've loaded in here from an IDF file. We can sort of mouse over the components here. So I'm going to just bring down the simulation domain a bit. So we've got a sort of long, thin cuboidal box. And what I'm going to do is just add a inlet condition on the left side here. So we've got a sort of, fan that's driving some air in on the left. So yeah, let's make it there, but let's just line it up a little bit with the PCB so the airflow goes over it a little bit better. And so then, yeah, the first feature I'd like to show off that's new is we've added the ability to load step files into the simulation domain. And so that means we can ingest geometry from any, major CAD software. If you can export it as a step, you can now load it in here. So we've loaded in this cube step file. This is just to keep things nice and simple so we can run a simulation quickly. So I'm just going to position this cube just down the end of the domain here. Okay, and that's inside. And then what we've got as well is we've added the ability to set boundary conditions on the surfaces of CAD parts as we load in. So I'm just going to set this as an outlet here. So we've got flow coming in here, and let's just say we've got some structure here, but the actual air is going to be leaving the domain through this surface here. Now, here on the components, we can have a bit of a closer look at our PCB. So these are the various components on the board, and we can look at their conductivity and their power. But what I'm going to do is there's quite a lot of components here, so it's going to be quite complex to simulate all of them. So what I'm actually going to do is I'm just going to cull some of the smaller components just to, again, simplify the simulation to make it run nice and quickly. And so what we've got as well here is we can fuse some of the nodes that are nearby each other. And so that, again, just makes it a bit easier for the solver. So what we've added as well is the ability to configure like a turbulent boundary layer mesh. And so we can configure the wall distance. This is really important when you've got like turbulence in your fluid simulation, because the way that you resolve your mesh at the interface between a solid object and your fluid flow is very important, and for solving the fluid flow accurately. And you need to solve that fluid flow accurately because that boundary layer influences very strongly how heat is transferred from a component out into the fluid. So this is going to have a big effect on accurately resolving the temperature of your components. So, but this is nice and easy to configure now. I'll leave it at quite a large wall distance, which means the simulation should be, again, relatively quick. So what we've also added as well is the K omega SST turbulence model. And again, this is contributing to doing a better job of modeling those turbulent boundary layers. So I'm just going to kick this simulation off now. And in the meantime, I can just show you as well, we've added the ability to load in Gmesh mesh files as well. So, Gmesh is a commonly used open source mesh generation tool. And here we've got a example mesh file. This is just a slightly more complex geometry, you can see, and we can just sort of move that around. But I'm not going to use this in the simulation. That'll just have what we've already loaded in there. And what we've got as well here is some additional boundary conditions. So we've got an adiabatic wall, which would be like an insulating wall. We've got a fixed temperature wall, and so that would be like if you've got a part of a case which is at an ambient temperature, fixed temperature, you could use this as a boundary condition. Otherwise, we have a heat flux, which is, if you've got a CPU generating a particular amount of power, you could use that to configure it. Okay, so our simulation is done here. That's great. Now we can have a look at the flow field plotted through the streamlines. So the streamlines, we've added coloring of the field depending on the temperature of the fluid at the various points in the domain. So as we can see, basically, Flow is coming in here and it's flowing over the PCB, and where the fluid flow is fast, it tends to be reasonably good temperature. But what you can see here is that in between these two big components, we've got a bit of a stagnant region, and the components are a bit hotter, which probably matches with what we'd expect. So we can see the flow comes over here, we've got some recirculation regions, but then actually it's going out eventually through the outlet surface we defined on this CAD part. All right, guys, thanks for watching. Yeah, we're continuing to push out new features on this every week, and we're really excited to start testing this with some early users. So we're going to be looking to bring on some, closed alpha testers over the next couple of weeks. Yeah, keep you posted.